All right, everybody, welcome back to another deep dive. Today we're tackling something that might seem pretty simple at first.
Mixtures.
Mixtures, yeah. But stick with us.
Yeah.
Because separating these things, it's actually way more interesting and way more useful than you might think.
Yeah.
This isn't just about mixing up ingredients for a recipe or something.
Right.
This stuff is everywhere. It's essential in everything from purifying your drinking water to
Developing life-saving medications.
life-saving medications.
Yeah.
So let's start with the basics. What exactly is a mixture?
Well, a mixture, in the simplest terms, is what you get when you combine two or more substances, right?
Right.
But here's the thing. They keep their own unique properties. It's like
Like a salad.
like a salad, exactly. You got your lettuce, your tomatoes, cucumbers all hanging out together, but
They don't actually change each other.
they don't change each other. They just coexist.
That makes total sense. So how do we actually separate these ingredients, the ingredients of our scientific salad?
All right, so let's dive into some separation techniques. First up, we have sieving. You've probably seen this with sifting flour, right?
Oh, yeah.
But it's not just for baking. Think bigger.
Oh,
Construction workers use it to separate gravel. Scientists use it to classify soil particles. What's really cool is that the shape of the particles actually matters, not just the size.
really?
Oh yeah, different mesh shapes. They can separate things based on their geometry, not just how big they are.
Wow. That's way more complex than I thought.
Right.
Okay. What about magnets?
Oh, magnets.
Everyone loves magnets.
Yeah. I mean, who hasn't played with magnets as a kid?
Yeah, picking up paper clips and stuff.
Exactly. But it's not just child's play. It's essential for separating magnetic materials from a mixture.
Okay.
And the strength of the magnet, that plays a huge role. We're not just talking about picking up paper clips here. You got these powerful electromagnets used to sort scrap metal.
Oh, wow.
And even in labs, they use them to isolate specific magnetic compounds.
That's impressive. All right, so what about filtering? That one seems pretty straightforward, right?
Yeah, filtering. Essentially, it's using a barrier to separate a solid from a liquid. Think about your coffee filter.
Oh, yeah.
It keeps the coffee grounds out of your cup,
Exactly.
but it goes way beyond that. Think about air filters in your car, right?
Hmm.
Or these sophisticated systems that purify water on a massive scale.
Huh.
And what's key here is the pore size of the filter.
The what?
The pore size. So a coffee filter, relatively large pores.
Okay.
But for water purification,
Yeah.
those pores need to be incredibly tiny to remove microscopic contaminants.
Oh, wow. That's amazing. To think something so simple is actually so crucial.
Yeah.
Okay, so we talked about separating mixtures, but what about solutions? Isn't that like a special kind of mixture?
You're absolutely right. A solution is formed when one substance dissolves completely into another. Like if you think about sugar dissolving in water, you can't see the individual sugar crystals anymore. They're just gone.
Yeah, it's like they just vanish.
Yeah.
But then the water gets sweet.
Exactly.
So what makes something dissolve faster or slower?
Well, there are a few factors. Stirring, for one, because it increases the interaction between the substances.
Okay, yeah, that makes sense.
And the size of the particles matters, too.
Okay.
Crushing a substance into smaller pieces means more surface area is exposed, and that speeds up dissolving.
So powdered sugar would dissolve faster than a sugar cube.
Exactly.
Okay, that makes sense. Does temperature affect things too?
It does.
Because I feel like sugar dissolves faster in hot tea than in iced tea.
You're absolutely right. Temperature increases the energy of the molecules, making them move faster and interact more, and that accelerates dissolving.
Huh, interesting. So is everything equally soluble?
Not at all. Not at all. Some things are more soluble than others. For example, sugar is more soluble in water than salt,
Okay.
and some things won't dissolve in water at all, like sand.
Right.
There's actually a concept called a solubility curve.
Yep.
A solubility curve. It shows how much of a substance can dissolve in a certain amount of liquid at a specific temperature.
Okay, solubility curve. You're just showing off now. All right, so how do we get those dissolved substances back out? Can we reverse the process?
That's where evaporation comes in. If you heat a solution, the liquid evaporates, leaving the dissolved solid behind. A classic example is how salt is produced. Seawater is evaporated, and what you have left? Salt crystals.
Oh, yeah. I've seen pictures of those incredible salt flats. It's amazing.
Yeah.
So it's not just basic chemistry experiments here. We're talking about how essential products are actually made.
Absolutely.
Wow.
And don't forget about things like maple syrup. Evaporation is used to concentrate the sap, making that delicious syrup we all love.
Wow. Who knew there was so much to learn about mixtures? We've covered sieves, magnets, filters, solutions, evaporation. It's amazing how these techniques are used everywhere, from everyday life to like huge industrial processes.
It really shows you that science isn't just some abstract concept. It's happening all around us, all the time.
So here's something to think about. What mixtures do you encounter every day?
Yeah,
And how could you separate them? Could you come up with your own separation method?
that's a great challenge.
It really makes you realize that science is all about exploration and discovery. So keep asking questions, keep experimenting. Who knows, maybe you'll revolutionize the world of mixture separation. Join us next time as we dive into a whole new topic. Until then, stay curious.
Bye!